Welcome back to Arxflix. Today, we're diving into a fascinating paper titled Lost in the Middle: How Language Models Use Long Contexts. This research investigates how well current language models utilize long input contexts for various tasks. Here's a key visual from the paper showing the performance curve of language models as they process information placed at different positions within the input context. The U-shaped curve indicates that models perform better when relevant information is at the start or end, and struggle with information in the middle. Modern language models can process long sequences of text, sometimes spanning tens of thousands of tokens. But how effectively do they actually use this extensive context? The researchers tackle this question using two specific tasks: multi-document question answering and key-value retrieval. In multi-document question answering, models are given several documents and must extract relevant information to answer a question. They systematically varied the length of the input context and the position of the relevant information. Here's an example of what this task looks like. The highlighted document contains the answer. By shifting the position of the relevant document within the context, the study reveals that model performance is highest when crucial info is at the start or end of the context, forming a U-shaped performance curve. Check out this performance chart that clearly shows the U-shape. It seems that language models have both a primacy bias, better with info at the beginning, and a recency bias, better with info at the end. Even models designed to handle longer contexts, like GPT-3.5 Turbo 16K, don't show a significant advantage when the relevant information is in the middle. This suggests an inherent limitation despite extended context capabilities. Next up, they evaluated with a synthetic key-value retrieval task, where models identify values associated with keys within a long list of pairs. This task strips down the complexity to basic token matching, avoiding semantic nuances. Results were again consistent with the U-shaped performance observation. Some models performed this task perfectly, but others lagged notably when the key-value pair was placed in the middle. The figure shows that, just like in multi-document QA, performance drops when the relevant info is in the middle of the context. To understand why, the researchers examined various factors: model architectures, contextualization strategies, and the impact of instruction fine-tuning. Encoder-decoder models generally performed better, showing more robustness to changes in the position of relevant information, but only within their training time context lengths. Beyond that, even these models showed the U-shaped curve. A clever trick was applying query or contextualization, placing the query both before and after the input data. This improved performance on the key-value task, but had minimal impact on the more complex multi-document QA task. Surprisingly, the study found that instruction fine-tuning, often thought to improve context usage, didn't eliminate the U-shaped performance curve. Both instruction fine-tuned and non-instruction fine-tuned models showed similar trends. Even with additional fine-tuning, the performance still dropped significantly when the info was in the middle. The findings indicate that more context isn't always better. Providing long texts increases the data the model must process, often leading to reduced accuracy, especially when the relevant information is centrally located. Here's an example from their study on open domain question answering, showing that model performance saturates with context size well before the retriever recall does. In summary, this study provides crucial insights into the limitations of current language models' use of long contexts, highlighting a significant area for future research and improvement. If you're interested in digging deeper, all the code and evaluation data from this study are publicly available. Thanks for watching Arxflix. Don't forget to like, subscribe, and hit the bell icon for more in-depth paper summaries. Until next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.